All right, let's get started. Welcome everyone to today's webinar, and thank you very much for joining. Today we have the webinar Getting Started with Kubermatic Kubernetes Platform Part 2. And in this webinar, you will learn how to create the initial Kubernetes cluster that you need in order to set up Kubermatic Kubernetes Platform. By the use of KubeOne. And KubeOne is an open source CLI tool for installing, managing, and upgrading Kubernetes clusters that can be used on any cloud, on-prem, and also on edge and IoT environments. In case you have questions, we will have a short Q&A session after the presentation, so we can answer your questions. And also, in case you need to drop out early of the session, no worries. We are recording this meeting and we'll share it with you via email after, in the coming days. And with this, I already want to hand over to our two speakers today, Sebastian Scheele, the CEO and CTO of Kubermatic, and Marco, who is a software engineer at Kubermatic and is like doing a lot of stuff for the KubeOne project. Yeah, so enjoy.
Thanks, Chrissy, and welcome everyone. Let's introduce quickly ourselves. As Chrissy already said, Sebastian Scheele, co-founder and CEO of the company. We started the company roughly 4.5 years ago, and today with me in the call is Marco. Do you want to quickly introduce yourself?
Hey everyone, I'm Marco Mudrich. I am software engineer at Kubermatic. I am one of the core maintainers of the KubeOne project, and I'm happy to be here to share what we have with you all.
Yeah, and so first, time to watch or participate in the last webinar. Give quickly a quick recap about Kubermatic. So we were before Lutze rebranded the company now to Kubermatic and also open sourced Kubermatic, and we are one of the top employer here in Germany. One of the top committer to the Kubernetes project. In general, one project where we're actively, heavily working on is the Kubernetes dashboard, but also upstream Kubernetes, cluster API, and many more projects. With a quite distributed team here in Europe, based in Germany from the headquarters, but like 10 different countries. Marco is Serbia, so really working on Kubernetes and cloud native technologies. And the agenda for today is first we want to discuss how KubeOne fits into the Kubermatic Kubernetes platform architecture, a quick introduction about KubeOne, what were the ideas, why we do it, and then we will show you how to create a cluster, upgrade cluster, how to manage worker nodes, and a quick introduction also into machine control and cluster API. So with this, you will be prepared to having the foundation, and in the next webinar we will look then into how to deploy on top of KubeOne Kubermatic itself. But let's have quickly a recap about the last webinar and the architecture. When we're looking into how Kubermatic Kubernetes platform works is it's an operator, and one essential part it needs to run on Kubernetes. And this is where KubeOne comes into the picture. So we use KubeOne to set up an initial Kubernetes cluster, and then we deploy Kubermatic on top of it, and then using this KubeOne cluster to also deploy the user master on top of this cluster, and then deploy the worker nodes on the different cloud providers. We every time had this chicken egg problem that we first need a cluster, and that's the reason why we decided we need to build KubeOne. And but KubeOne already leveraging a lot of technologies from Kubermatic Kubernetes platform. So when we later look into the machine controller, for example, that's used on both platforms, there are a lot of similarities. The main difference is KubeOne running the masters as VMs, where on the other side, with Kubermatic, we're running the masters as completely containerized environments. So as I already said, KubeOne is a tool for managing Kubernetes cluster. It can install and provision Kubernetes cluster, upgrade cluster in the classical way with like VMs or bare metal machines for the master, and also the worker nodes. And completely open source, you find it on GitHub. It's provider neutral, so it can run on a lot of different providers, the big hyperscalers, AWS, Google, Azure, but also on-premise, also working on, we can run on ARM processors, so you can even use KubeOne to deploy it on Raspberry Pis. We support all upstream Kubernetes version, and similar as we are committed with Kubermatic Kubernetes Platform itself, running and supporting to be as close as possible to upstream. The same commitment we also have here for KubeOne, that we are really close to the latest version of upstream Kubernetes, and that you are every time can use the latest version on this. Why we decided to build KubeOne? So one of these things is we needed a way how to manage the workload, and one of our main workload was really like Kubermatic itself. So what we figured out is it's still hard to manage clusters, and so we decided we have every time this chicken egg problem, we need a proper solution there. And then we decided, hey, we're doing this all time long. We have a lot of components in our core product. Can't we use this to manage to build a tool which helps us to get this bootstrapping solved, so that we can get the cluster running and going that way. Yeah, we want to apply lessons we learned from managing workloads. Also for customers who only have 1 or 2 clusters, we're potentially first spinning up a master cluster and then putting our Kubermatic Kubernetes platform on top of it is over-engineered. Customers now have also the capability to run only individual clusters with KubeOne. And the whole idea was also that we can do this in a declarative way, so that we can create a cluster, we are able to upgrade the cluster without any scripts, and also leveraging a lot of learnings and technologies we already built, which were already, like the machine controller, were already out there, open source. So we said, okay, let's build something that is really usable. And yeah, so we wanted to have a feature complete solution which also works on all the provider where our main product can work, so that we know, okay, if we want to set it up on AWS or Google or on-premise on VMware, and we can go all the way down because we're leveraging a lot of the same technologies and can leveraging this power also for KubeOne. Yeah, so on the feature side, as I already said, it's open source, provider neutral. You can run it on a lot of different providers. Integrating new providers is quite easy, and it can install, upgrade, repair, and unprovision your cluster. We have support for different operating systems, Ubuntu, CentOS, and RHEL, CoreOS / Flatcar now. It's really a declarative cluster definition. And also we are provisioning the worker nodes in an automated way. And what we're leveraging there, kubeadm, so it's completely compatible with it, and we're leveraging it. You can optional combine it with, for example, Ansible, Terraform to provision the initial VMs for the master. But that's not a requirement. For example, on bare metal machines, you can also, if the operating system is also already provisioned, directly use KubeOne to provision only the Kubernetes cluster on it. But you can integrate it with other tools, also tools which are not mentioned here. And the idea is really, when you use it, it's battery included. You get a running cluster. You can easily set up like OpenID Connect or access management for it. Things like pod security policies. We have also the capability to deploy additional add-ons on the cluster. So if you provision a cluster and need additional capabilities, we can then use this, having things like a jump host support, and you can use it in proxy environments. On the provider, we want to be really agnostic. So there's a lot of lists we are already providing on supporting AWS, Azure, DigitalOcean, Hetzer. We're working on also including more. But if you see something is missing, feel free to ask us if you have it on the roadmap. But we also can advise you and tell you what things needs to be added. It's really straightforward to add new provider to KubeOne. So if your provider is not in this list yet, yeah, create a PR or contact us, and we can look into how we can support you on the journey. How do you get it? There's an easy way. If you go to our GitHub, you find a curl command, or it's also mentioned here, where you can install KubeOne. You can also use it with Go modules or directly downloading the binary and the latest release from GitHub. The current recommended version is the V1 beta. So if you want to use all the latest features, the V1 beta version is out there, and working on that, you will get the GA version soonish in the next months. And yeah, we're really happy the beta was released today. So crossing fingers with Marco that everything works during the demo. And yeah, now I want to hand over to Marco, who will show you how it works and how you can use KubeOne to spinning up Kubernetes cluster.
Thank you, Sebastian. I will now take over just to share the slides again for a moment. Okay, now you should see the slides again. So what we're going to do now is that we are going to create a cluster using KubeOne. Then later we are going to see how we can upgrade it and do all the other stuff that are usually done. Let's start with some architecture overview. As Sebastian mentioned, we use many tools and solutions as building blocks, like the first one and mostly important KubeADM. We use it to provision and join contemplate nodes, as well as handle cluster upgrades. Kubermatic machine controller, which is based on cluster APIs, used to manage working nodes. The environment is prepared over SSH, which means you need to have SSH accessible instances, and you just provide IP addresses information how to connect to KubeOne, and KubeOne does all the setup, like installing packages, provisioning Kubernetes, installing features, and so on. Once the cluster is provisioned by KubeADM, the client Go library is used to deploy various cluster features like CNI, pod security policies if enabled, and so on. What are our some goals for today? First, we are going to start by setting up infrastructure. We are going to use Terraform for it to show how you can easily integrate Terraform with KubeOne. One of the core things we are going to focus on is networking, load balancers, firewalls, security groups in context of AVS, and of course, instances. Once we have the infrastructure, we are going to set up highly available Kubernetes control plane. There's going to be 3 control plane nodes, 1 control plane per availability zone, and there is going to be a load balancer that is going to be in front of those nodes and Kube API server. And at the end, we are going to see how machine controller works by setting up some working nodes. And we are going to have a cluster API-based machine deployment, 1 per availability zone. Now, let's see a bit how it is some high-level overview. So this is from the operator side. We have the VPC. VPC is provided by the operator. Then KubeOne, actually Terraform scripts that we ship with KubeOne. Those are example scripts that we are going to use today that you can take as an example, that you can modify and do whatever you want to them, or use them as they are. In the VPC you given, they create the Kube API load balancer that is pointing to all control plane hosts, mostly to Kube API server. We create 1 subnet per availability zone. where instances are, and we create one host for control plane in each availability zone and each subnet we created. Also, we create a Western host in first availability zone and first subnet. This host is used because control plane hosts don't have SSH accessible to public subnet to internet, but they can be only accessible via Western host. It improves security a bit, especially if you decide to use totally private setups. So it works like that, and KubeOne uses it to connect to other instances. We are going to see how it works a little bit later. From the user side, as the cluster is there, we have the user that is going to use kubectl or API or whatever to access the cluster. The access is going over the Kube API load balancer that we created before, and it points to all three control plane hosts. But you see now that once we created a cluster, we have a working node per each availability zone. It is time to see what are steps needed to create the cluster. And the first one is to create instances and infrastructure. As mentioned, KubeOne comes with some example Terraform scripts that are a good starting point. We are going to use them for today. Second step is to build the KubeOne configuration manifest. It defines stuff such as what Kubernetes version will be used, what instances will be used, how the cluster will be provisioned. It says what features will be enabled and how they will be configured. Third step is to run the KubeOne install command. And after the command is done, we can enjoy our newly created cluster. At the second step, I mentioned that we create the configuration manifest. And if you use Terraform for integration to provide information about instances via that integration, the manifest can be simple as this one. The easiest way to obtain it is to run KubeOne config print command, and it is going to bring you a similar manifest to your terminal. It will include some additional fields that are optional and defaulted by KubeOne, even if not provided. So as minimal as this manifest you can use to provision the cluster. Some important information is that we first provide the API version in KIDE, like for any other Kubernetes object. The new for V1 beta release is that now we use the V1 beta 1 API. If you used KubeOne before with all the releases, there was an alpha API, but now we are happy to announce that we have beta 1 that is a little bit better in terms of user experience, and we hope that you're going to like it. You define the versions, and for Kubernetes, 1.18.4 is one of the latest ones. And you define the cloud provider. In this case, we are going to use AWS, and AWS doesn't take any options. And for such providers, you just provide these brackets, and that's enough. As I said, KubeOne provides a lot of configuration options. And the easiest way to get the manifest config that have all those options that you can enable is that you can run KubeOne config print --full. And you can see that there are stuff such as features where you can enable pod security policies with comments about how it works and where you can find more information. Static audit log, dynamic audit log, and much more. Or you can define stuff such as cluster network, where you can define subnets, or where you can choose what CNI you're going to use. We provide three options. The default one that we are going to use today is Canal. This is a combination of Calico and Flannel. But there is also option of VNet, which, for example, provides encryption. So if you need it, you can use it to enable it. And we have external option that you can use the combination of KubeOne add-ons mechanism and to deploy the CNI whatever you want. So let's take the overview of the installation process. First step is we provision the infrastructure. We create the KubeOne config manifest as seen on previous slides, and we provide all those information to KubeOne. And KubeOne takes several important tasks. The first one is to provision the cluster. That includes that KubeOne installs all needed packages, configure everything that needs to be configured for Kubernetes to work properly on the instance side and operating system side. Then we install kubeadm, kubelet, and other packages. We run kubeadm. Once the cluster, we do it on all 3 instances, and once the cluster is provisioned, we download the kubeconfig file, which you can use to access the cluster. Then we configure and deploy features and things you have chosen, like CNI, some add-ons, and stuff such as that. And at the end, we create and provision working nodes. Once that is done, you have the fully functional cluster that is ready to use. Now, it is time that we see a quick demo of how that works. So the Terraform scripts are located in the examples directory in KubeOne repository. There you can find some Ansible and Terraform. For today, we are focused on Terraform. And there you can find the Terraform configuration for each supported provider by KubeOne. We are going to take the AVS for now. This AVS demo you see here is for demo purposes for today. It is same as this one AVS we are going to see now. What files we have here? We have the config manifest that we have shown on the slides, and we have Terraform files that defines how the infrastructure is provisioned. We are going to take a quick look. So we take some information like the variables with cluster names, tags, and so on, work your operating system. We read information about the available availability zones, about the AMI that we are going to use, about the VPC, Ethernet gateway, default VPC, and about the CDR block for subnet that we are going to use. Then we get to creating part. We start with networking. We create the subnet in each availability zone. Then we create a firewall or security groups that increase the security of setup a bit, that you can only access over the load balancer API server, that you can't access instances directly over SSH, but that you have to use Bastion, and so on. And once security groups are created, we create the LB that is going to be used for Kube API load balancer. We point to the instance ports for Kube API server default port. We define the health checks and whatever is also needed. We deploy the SSH key that's going to be used to access the instances, the needed IAM roles and profiles. And finally, we get to create the control plane instances, 3 of them in each availability zone for control planes. Note that we don't create for working nodes for now. That is going to be handled by machine controller component, and we are going to see a little bit later how exactly. And the Bastion host, one of it, is the first availability zone. What else we have, which is reported, is variables. This is all the options that you can use to configure how the cluster will be created. The most important one is cluster name. You have to provide it so KubeOne can use it to configure everything to use that name. Instances will be created based on that name, and so on. You can choose the worker OS. The valid choice are Ubuntu, CentOS, Flatcar, and RHEL. There you can provide the SSH information that is going to be used to access the instances. And there are information, these two, about how to access the Bastion instance if it has different setup than control plane instances. Then we define the region, VPC ID, control plane type, like the volume size, and so on. This is everything that you can configure, like the operating system for control plane instances, or if you want to provide AMI. There are several options. We are not going to go to each of them now. But in the KubeOne repo, you can find documentation in the README file for what each option does and what is the requirements. The easiest way to use these variables is to use this Terraform tfvars file. Like, you can define cluster name. In this case, it is webinar period 1. And I define the SSH public key file as ssh terraform rsa.pub. So a typical one, nothing special. The Terraform reads this file automatically, and it is the easiest way to provide any customization. Finally, regarding the Terraform side, output EF is very important if you want to use the Terraform integration. This file provides in what format the Terraform state will be outputted. It is very important to strictly follow it so KubeOne can parse all the information. We first define the API server load balancer endpoint. Then we define control plane hosts. This is the cluster name, the cloud provider, addresses, host names, bastion information, if it is used. If not, you can omit that part. It is not required to use bastion, just to mention it. And then we define workers. For workers, this is going to be transformed into machine deployments manifest that is going to be applied on the cluster once it's created. By default, as mentioned, we create 3 machine deployments, each per availability zone, and you define information like the name of the machine deployment object, number of replicas, by default it is 1. It can be easily scaled up and down, so no worry if you don't like the value later. Then we define the operating system, information about the cloud provider spec. The good thing about the Terraform integration is that you don't have to worry about all of this. You can just read it for Terraform. The KubeOne integration is going to parse it and to fill all the information about instances and for all other inavailability zones. Now, this is for AVS, and if you want to change any option, I just want to mention that on machine controller repository, you can find the examples directory where you can find manifests for each supported provider. Like if you can go to AVS, you can see the interesting part is this provider spec. This is what goes in Terraform output file. And then you can omit some stuff such as the access key ID and secret. This is populated automatically, but this is what is important to you, so you can read what are all info options that you can use. And now that we have seen this, we can use this to create infrastructure. And it is done that you run Terraform apply. And here you can see that it shows what is it going to create. And there are 19 resources. More information about them is available here. It takes about 50 seconds up to 1 minute to create this. And we are going to wait for a bit for this to be done. This should be quick. So in meanwhile, we can take a look at the configuration file, config YAML, same as one shown in the slides. The only difference I want to mention is this, that we are going to use 177 so we can show the upgrade process later. Now we can see that it showed the output. What we want to do is to export this output to a format readable by KubeOne. Terraform has a command for that, so you can run Terraform output period JSON, and we can call it tf.json. We can see the file is here. If we open it in editor, a lot of information about the API, about the objects that it has, and about the values. One thing to mention, if you decide not to use Terraform, you can create the infrastructure yourself, or maybe you can have the infrastructure. You already have the infrastructure. You can run kubectl config print --full, and here at the control plane part, you can see this, and this is the hosts, and you can see that you can provide public and private addresses, bastion support, bastion information if you have it, SSH information, and so on. This is automatically provided by if you use Terraform integration, but if you don't, you can put all this in the config file that we have seen here. Similar for the machine deployments, you can also create dynamic workers. You can provide name replicas and everything that has been provided in the output.tf file in this configuration file. Once we have all pieces in place, we can use KubeOne to run and provision our cluster. The command is KubeOne install -- manifest flag takes the config file, and then we have -t tf.json, the path to the file that we have created with the Terraform output command. And the KubeOne has read all information and it has started its process. Now this process takes about 5 to 10 minutes. It depends on the provider that you use. It depends on the instance size and the speed of overall system. And since this takes a little bit longer, I have already provisioned a cluster, and we are going to switch to that cluster to see how it looks like. So first, what we have is complete KubeOne output. You can see that it starts by documenting information about systems, installing the prerequisites that needs to successfully run Kubernetes. We create the needed files, install kubeadm, generate certificates and configuration file, and distribute them to all 3 control plane instances. Once that is done, we run kubeadm, and we take the kubeconfig file, build the Kubernetes client set, use it to access the cluster. Then we check if cluster needs any repairs. Once you run for the first time, of course, there is no need for any repairs. But if you use KubeOne install to repair this cluster, this step is going to take care of that. In the KubeOne documentation, you can find officially and detailed how you can do it. Then we join the remaining control plane nodes. Then download the kubeconfig file on your local machine. Activate additional features, deploy node local DNS cache, apply kernel CNI plugin. Add-ons are not enabled. You enable them by providing them in the manifest. In the config printful, you can find more information about that. We create the credential secrets that contains the credentials used by machine controller and eventually by Cloud Controller Manager to access the Cloud API to create instances and take information about them. We install machine controller, wait for it to come up, and then we create working machines. Once it is done, you can see here that kubectl get nodes return 6 nodes, all running 177. Nodes marked with role master are our control plane nodes, and the remaining nodes are working nodes. Now let's quickly switch to slides again. And let's see how to actually manage working nodes and how machine controller works. There are 2 ways to manage working nodes. The first and most recommended one, if your provider is supported, is to use Kubermatic machine controller. And in some cases, like if you run for bare metal for IoT setups where machine controller can't provision working nodes, it is also possible to use KubeOne. We are not going to go into details about this for now. Similarly, in our documentation and the kubeconfig print-full, you can find here the static workers. This is the workers provided by KubeOne. Similar to how it takes information about hosts for control planes, it takes the similar information here as well. But now a little bit about the machine controller. Kubermatic machine controller is an open source cluster API implementation. Cluster API is declarative Kubernetes style API for cluster and machine management. It includes creation, configuration, and management. You define what you want in form of manifest, and controller creates it for you. In our case, that's machine controller. The general overview is a set. User provides declarative config. It takes the machine deployment. It provides it to the Kubernetes cluster. The cluster API controller creates the instances. It works on many providers like AWS, vSphere, GCP, Azure, and more. But how it exactly works? There is 3 types of objects. The most important one is machine deployment. It is similar to deployments. We also have machine sets and machines. In the machine deployment object, you define the number of replicas and cloud provider specification, such as what provider is going to be used, but also information how the instances will be created. Then, once you create machine deployment objects, machine controller automatically creates machine set and machine objects. And once the machine object is created, it triggers creation and provisioning of cloud instances for working nodes. And machine controller, besides that, all the time watches machines. So if some machine or node becomes unavailable or unhealthy, it will be recreated. If the machine deployment object is changed, for example, upgraded, the version is changed, or the replicas is changed, the machines will be rolled out, new ones will appear, or old ones will be deleted depending on the operation. This system is very similar to what we have in Kubernetes. We have got used to deployments, to replica sets, and to pods. And this is very similar. We have machine deployment, which is similar to deployment. We have machine set, which is similar to replica set. And at the end, we have machine, which is similar to pod. Now it is time to upgrade the cluster. But before, let's see a little bit of tips and tricks regarding machine control. Get back to the cluster that we provisioned earlier. We have seen the nodes, but if we run like kubectl machine deployments, by default, they're deployed in the kube system namespace. We are going to see 3 of them. As said, this cluster is named webinar 2. The region is EU West 3, and we have each vulnerability zone A, B, and C with 1 replica, and it shows the number of available replicas. This is 1 on AVS provider running Ubuntu 177. If we run kubectl machine sets and kube system, you're going to see machine set for each machine deployment. And finally, if you run machine, get machine, you're going to see, because we have 1 replica for each machine set and machine deployment, 3 machines running on AVS, and with information such as addresses. If you run like kubectl get describe machine in kube system, you're going to see some more information such as the IP addresses, references, and events. You can use these events, especially useful if something goes wrong. You can easily debug and find out what happened. But that's not only the positive part of machine controller cluster API. The good thing is that you can easily scale up and down and create new machines using kubectl. We are now not going to show how to create a new ones using kubectl, but in the machine controller repo, we have seen examples. You can use this manifest to create a new ones, but you can use the kubectl to scale existing nodes and machine deployments. And this is done that you can run kubectl scale. And we provide resource name, it is machine deployments. And we provide the namespace, it is kube system. Finally, a name. Let's scale this one in B. And we can say replicas equals 3. And when you run kget machine deployments in kube system, you're going to see that there are 3 replicas. 1 is still available. It still haven't got provision on the join it. It takes a couple of minutes, sometimes 2 or 3. And if you run get machines, machine sets, and machines in kube system, the machine set has been changed to 3 replicas. And we can see that now we have 5 nodes, and they have already got their IP addresses and are in process of provisioning. One good thing that you also can do is that if you don't need sub machine, but you don't want to delete it, you can, for example, take it with the scale command and say replicas equals 0, And when you run kubectl get machine deployment, you're going to see that it's 0. It doesn't show available replicas anymore. The machines are marked for deletion. We still see them here, but if we run kubectl get nodes, we can see that that one that was in that availability zone has been marked with scheduling disabled. It is being evicted, and after several minutes, it will disappear. Now, to get back at slides and upgrading the cluster. So it is very important to keep your cluster upgraded. Kubernetes has new versions, the minor ones 3 to 4 months, but patch releases are even more at several weeks. Some of them bring some fixes, like the recent ones had the fixes for 2 CVEs. So it is important that you can easily go ahead and upgrade your cluster without worrying that something is going to break or that you have to take a lot of manual steps that you're not sure about. KubeOne takes care of that for you. You just need to run the KubeOne upgrade command and the cluster is going to be upgraded. Some architectural information about upgrading process. The control plane nodes are upgraded in place. They are not rotated. We run the scripts that takes care of upgrading packages, the binaries for Kubernetes, the core Kubernetes components. This is done by kubeadm, and they upgrade stuff such as Kube API server, scheduler, controller manager, and all the other stuff that is needed for healthy Kubernetes cluster. And at the end, all components deployed by KubeOne are also upgraded at this step, like CNI, machine controller, and so on. Working nodes are upgraded a little bit differently. If you use machine controller, they're rolled out. The version will be changed. Machine controller would add a new working node that is running the latest version. Once it is healthy, old one will be removed, just like when you roll out a deployment, the typical one for Kubernetes. And after some time, you will have the fully upgraded cluster. So how it works? Similarly, you provide KubeOne config manifest and information about the infrastructure. KubeOne runs some pre-flight checks. It assures that you can upgrade to desired version, that cluster is a healthy state. Then it starts the upgrade process that we described. After that, it checks all components up to date and upgrades needed components. And optionally, if you chose so, roll out the working nodes. Result is fully upgraded with functional Kubernetes cluster. Now we can get to a demo. Let's see what happened with this cluster. So if you kubectl get nodes, we can see that we have got some more nodes, but the one we have deleted has disappeared. Like we can't find it really anymore. So we can use this cluster to upgrade it. And we are going to run the code editor. What we want is to change the configuration manifest. This is the one that we have used before. And to trigger the upgrade process, everything you need to do is just to change this version. We are going to use 1.18.4, for instance. And we save that file. We can now close the editor. And what we need to run is the KubeOne upgrade command. Similar to the previous one, it takes the path to the manifest. It is config.yaml. It takes the path to the Terraform output state. In previous example, here when we run KubeOne, we used this tf.json with the command that generated this file. This is Terraform output command that we can see above, like this one. We have used to generate this file, but you don't have to worry about it. KubeOne can also take care of that for you. You can just provide the directory where the Terraform state is located. In our case, and we want to say that we want to upgrade machine deployment objects. So we will take this flag and we are going to run the process. It starts the similar way. It determines the host name, the operating system, run the pre-flight checks, and it drains node, prepares it for upgrade, makes it as that it can be used again for all 3 nodes, components upgraded, machine deployments rolled out, and we have a functional cluster. Now, this process is also taking between 5 or 10 minutes. We are not going to wait a lot for it to finish. We are going to go quickly through the slides, and maybe we will have time to see how it looks like, but it is not spectacular. It is just that KubeCat nodes will report the latest versions. So we are back at this architecture diagram. And as Sebastian mentioned at the beginning, we have used KubeOne to create this initial cluster, the admin cluster, where we are going to run the Kubermatic Kubernetes platform. Now, we are not going to see how is it installed, but at the next webinar, we are going to show how you can install it, how you can configure it. So make sure to join us for the next one. Now it is time for questions. So go ahead if you have any.
Yeah, thank you, Marco. We do have the first 2 questions. I will start with the first one. Are there any plans to create a Terraform provisioner for KubeOne in the future?
Right now, we don't have such plans, but who knows? A good thing, if you have any feature request, you can always reach out to us. One good way is also to create a GitHub issue with your feature request, and then we can discuss and see, is there anything we can come up?
Yeah, and there should be the possibility to use the Terraform remote exec provisioner to include the KubeOne binary in this and using this to execute this. Or the local, I think you could use the local executor. So it could be, it should be possible. If you have specific requirements, please let us know.
All right, then the second question, also shortly, I gave you all the right to unmute yourself in case you have questions, so you can decide if you want to type them in the Q&A window or the chat or just speak up. We have the second question, does KubeOne handle persistent volume claims as well?
Depends on the provider. For stuff such as AVS and so on, they should be out of the box there. Not sure exactly right now, but they can be eventually created. It should work if they're not present. For some other providers, like the ones that don't have the CSI plugin integrated, you would first have to deploy CSI and then you can use persistent volumes.
Yeah, but you could include this in the add-ons so that you don't need to do it every time manually. You can configure that depending on your provider, and especially if it uses out-of-tree cloud provider integration, includes this into the add-ons. And then in the future, every time when you deploy a new cluster, it will be deployed automatically and you have PVC support out of the box.
All right, are there more questions?
Yeah, I think there's one more. What about or how to update the underlying operating system?
The underlying operating system is up to the operator. The KubeOne doesn't take care of that. So this is the reasoning for that is that we found out that it's more secure if we don't take care of that, because we can't predict what is really on the operating system, and it is best that you control it manually. So we don't take care of that.
It depends also, I mean, depending on what provider you are. For example, with the machines on the worker nodes, if you're providing a new AMI, we will roll out a new image and would roll out new upgraded VMs as well. So on that side, it really depends how the operation is working, and but KubeOne can be integrated in your existing environment, or also yeah, can help on this, but it's not like out of the box, because we figured out with customers, everyone is handling this a little bit different, and so we said, okay, that's we want to make it more optional for the customers to do this.
All right, more questions. Yeah, I can't see any more questions. Yeah, then we can, first of all, thank you very much for your time. You can, of course, find GitHub, KubeOne on GitHub under Kubermatic/KubeOne. Of course, we are always happy if you follow us on Twitter or if you provide us with new GitHub stars. We also have a blog where we share all our knowledge on Kubernetes related topics. And yeah, you can also join us on Slack to directly communicate with our developers who are working on KubeOne. And yeah, that is it. We will have the third part of our Getting Started with Kubermatic Kubernetes platform on July 15 at 6 p.m., so 1 hour later. We will send around the invite in the coming days, as well as together with the recording. And in the third part, you will finally learn how to install Kubermatic Kubernetes platform itself. So today we had part 2, getting started with KubeOne, and the third part is then the final part. Yeah, and we hope that we see many of you again for the third part. I thank you all very much for joining, and I wish you a nice day. Goodbye.
Thank you for joining us. Goodbye.
Bye.